Okay, good evening. Welcome to
Great Math number 69.
Great Math number 69. So I saw a really neat post from Richard Green today, who we've done a few projects based on his work. Can you give me the marker? And so he defines what he calls the complexity of a number, and I've never heard of that term before, as the number of ones you need to use to make the number using only addition and subtraction, or addition and multiplication. Okay? So for example, 3 is 1 plus 1 plus 1.
Yeah.
So the complexity of 3 is
3
But the complexity of 4
is, could it be 1 plus 1 times 1 plus 1?
Yeah, it sure could.
Or
1
it could
plus
be
1.
1 plus 1 plus 1 plus 1.
1 plus 1. Or, very good observation. It could be 1 plus 1 plus 1 plus 1. Either way, it seems like, how many are we going to need?
4.
4. Okay.
And is it the least number of
It's
ways?
the least number. Yeah. So we're not going to get too caught up in trying to prove whether we found the least or not. But I'm going to give you a couple challenges.
Yep.
Try 5.
Well, let's see. Well, 5, you can't use multiplication because 5 is prime.
Oh. Sneaky.
So it has to be 1 plus 1 plus 1 plus 1 plus 1.
Interesting. That's an interesting observation.
So 5.
Okay. Try 6.
Well, 6, you can either do it as 1 plus 1 plus 1 plus 1 plus 1 plus 1.
Okay.
Or you can do it as 1 plus 1 plus 1 times 1 plus 1.
Okay.
Which is 6. So the complexity here is 5.
Ah. So that's our first one that didn't have
The complexity of itself.
of itself.
It's 5.
So let's talk about 7 now.
Well, 7 is prime. So it's just itself.
Are you sure?
Well, actually, you can do 1 plus 1 times 1 plus 1 plus 1. So this is 1 plus 1 plus 1 plus 1. So the complexity would be 6.
Ah.
So,
6. So it was a good thought that you had about primes, and you couldn't multiply to get them.
But you can multiply to get like 1 less than them.
Yeah, you can multiply to get 1 less. So that's actually pretty interesting.
Yeah.
All right, you pick a number now, and this will be our last one where you calculate the complexity.
Let's see. Maybe 10.
10, okay.
10. Let's see, what could you do for 10? Well, you could do 1 plus 1 times 1 plus 1 plus 1 plus 1 plus 1. So this is 7 right here.
Ooh.
We can find another way to do it.
Ooh,
maybe.
7.
We can also do 1 plus 1 plus 1 times 1 plus 1 plus 1 plus 1.
Ooh, write that down.
So 1 plus 1 plus 1 times 1 plus 1 plus 1 plus 1. Either way, it's 7.
Ah.
But can you do any, let's see, and you can't use subtraction.
No, you can't use subtraction.
Well, you could do it, let's see. Well, if you could do 1 plus 1 plus 1 plus 1 plus 1, but if you could just write it all out again. So that would be 10, but it seems like it's 7, the lowest you can get.
It is 7.
Mm-hmm.
That's right. That's good work. That's really good work. So this is actually pretty neat.
Yeah. I wonder if you could find the complexities of big numbers.
Yeah. Well, I think there's mathematicians who are studying that. In Richard Green's post, actually, he talks about they figured out what the smallest number it could possibly be
Is
And they figured out, for any given number, they figured out a formula for the smallest number the complexity might be, and also the biggest number it might be, but they don't know how to find it exactly.
Well, we always know the biggest number.
Oh yeah, what's that?
Just itself. Because
Oh.
1 plus 1 plus 1 plus 1 plus 1 plus 1 plus
Yeah,
1.
it's a good point. Good point. We know it's got to be less than or equal to the number itself.
Wait, but it could be infinite.
What do you mean?
You could do 1 times 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 1 times.
Yeah, you're right. Now remember, but the complexity is the smallest number of ones.
Yeah, but you said you could find the biggest number.
Oh, sorry. I see what you're saying. Yeah, I meant the biggest number that the complexity itself might be.
Oh.
But you're right. It's got to be less than or equal to the number itself, no
Yeah.
matter what. So that's called an upper bound.
Yeah.
But they have some ways of even finding lower numbers, so it's got to be lower than. That's actually pretty neat.
Ah.
Pretty neat thing.
Yeah.
Okay, good. Thanks for doing this.
Okay.